Hello, everybody. Welcome to episode 2 of the weekly Quantum World Detangled. We are with Denise.
Hi, everyone. Denise Ruffner. I'm Chief Business Officer at Cambridge Quantum Computing. And Tommaso?
Hello, hi, good morning, everyone. Tommaso Demarie from Entropic Labs, calling you from Singapore.
And myself, André König, CEO of Interference Advisors, hoping to give you a little bit of the sunset here from Miami Beach overlooking the beautiful Miami skyline. We'll keep rubbing my Florida locations into you since we're a weekly but also worldwide global quantum detanglement effort, and coming to you from around the world again. You both are at home, I believe, as well,
Yep.
or have you managed to get outside a little bit?
Well, very little, as you can see. I hope you can enjoy the wall of my living room. Like André. Still fairly locked in the house here in Singapore. Situation is getting much better, but getting a little bit of cabin fever, if that makes sense.
Oh, you have some nice posters behind you. Are those movies or
No,
Italian movies?
they're not Italian movies. They're actually posters from the carnival of my hometown, which is quite a funky one. The town is called Ivrea, and once a year the town organizes this 3 days orange battle where people throw oranges at each other.
How fun.
It's amazing. It's absolutely amazing.
I want to go do that.
It's fantastic. We try to go back every year. This year we couldn't, unfortunately, for obvious reasons. But anyway, they always have these very nice posters. They try to make it a bit artsy, and I started to collect them.
We do that in Miami, throwing oranges at each other, but it's without the historic background.
And today we're in my kitchen. My husband threw me out of the office. He has a conference call, and so a little bit of a change of venue for everybody on the podcast. But here in Southern California, we're still very much at home. I think they're going to open up golf courses and hiking trails tomorrow. So actually, that's really exciting at this point in time. So it's all good.
Do you play golf, Denise?
No.
Okay.
No, I don't have the patience for it. But, hiking,
but it's the excitement is real. Yeah.
Yeah. Hiking is good.
Hiking is good, I agree.
Yeah. Can you golf? Do you golf?
Never tried once in my life, I have to admit.
None of us are golfers.
I don't golf. I count qubits. That's the only sport I'm interested in.
Okay. Tommaso was just telling André and I about a paper he read this week, and I thought we could start off by having you share that with everyone.
Yeah, sure. I actually try to do things slightly more professional, so let's see how that goes. Is not only one, actually, there's a few papers, and they're very recent. And before I start, can you see the page or not yet?
There it is. Yes.
Okay, cool. Yeah, I will try to keep it short. I don't want to get too nerdy or, dig too much deep into the details. But I think April was an amazing month for quantum computing, at least. And there have been really, really great work. I'll say moving towards applications, although, as we all know, that has to be taken with a massive pinch of salt. One paper that I really enjoy reading, I think it's a fantastic idea, is work from Aram Harrow. I mean, nothing new, right? The guy is absolutely fantastic, and his work is always excellent. And he came up just a month ago with this paper called Small Quantum Computers and Large Classical Data Sets. I think it makes sense to just spend maybe 30 seconds describing the idea. One of the potential applications of quantum computing is machine learning, or we could say a bit more precisely, data analysis. The problem with that is that in, I would say, most real-world scenarios, you have a huge amount of data, a huge amount of classical data, but the quantum computers available today are small, meaning they have a very small number of qubits. The coherence time is incredibly limited, and the depth of the quantum circuit is short as a consequence of that. And if you want to create an initial entangled state that contains the classical data set that you're going to analyze, is a problem, because you have a small quantum computer and a huge amount of data. And then Haro is suggesting a few techniques on how we could potentially solve that, or at least how we can start thinking how to use a small quantum computer to analyze large data sets. And you do that by basically analyzing what are called cosets. And as I promise, I won't get too much into the details. And maybe what I will simply say is that this is just a great paper that I believe goes in the right direction of being very creative, of using the computers that are available today to do something that is actually useful, potentially. And then there is a follow-up paper to that, which is called Coreset Clustering on Small Quantum Computers by the gentlemen. I'm not going to read their names. They are also often doing amazing work in this direction. And here they take Haro's idea and they push it a little bit forward. They test it on, if I remember correctly, the IBM quantum computers. And they start speaking a bit more practically, about benchmark results. I just love it. Just absolutely love it. They look at 2K mean clustering techniques. I think is a fantastic approach, and I really want to see where we can take it forward. Then there was the whole Google AI quantum effort in April. They came up with 2 papers, one on quantum chemistry and the other one on QAOA, which is the one I'm mentioning here. We at Entropical love QAOA, so I picked that specifically. It's great because, again, they're thinking, I believe, in the right way, which is we have a quantum computer with limitations. What can we do with it? How can we, accept the fact that there are limitations and still try to encode problems that are potentially relevant and starting to get results, starting to get a good understanding of what the limits are. And the last paper I will mention is one by Edward Witten, which is great, right? If you are into astronomy, you might know that there is this, it's called Planet 9, which is what seems to be a planet at the very far end of the solar system. Has never been observed, but there are gravitational traces of it. And here Witten is suggesting a very funky science fiction-y way to go out there and check whether indeed there is a big gravitational mass out there at the outskirts of the solar system, and how we could detect it if it's not a planet, but is instead a black hole, or primordial black hole. Because if it's a black hole, you can't see it if you just try to look at it in the same way you could see a planet. So you need to be very creative, and you need to check for the gravitational signs instead. This is really not about quantum computing, but this is a fantastic paper. I love it. It's very short.
I think Chickpea likes it too.
Oh, Chickpea loves it.
Chickpea likes it, the little bird in the cage, and we can tell how Tommaso is getting excited. I'm not even going to pretend to ask any questions, but obviously
I'm going to stop the presenting
QAOA and VQEs a couple of the big trends and getting value out of NISQ area machines in the short term. So an important topic that we'll get back into in more detail. Also within the context of the 1 million qubit question that we addressed last time. I think, Denise, you geeked out a little bit as well this week with some presentations that you watched.
Yeah, so it's funny. On last week's podcast, I talked about the IBM Think conference that was happening this week, and I completely missed the fact that there's a quantum devices conference at the Simmons Institute in Berkeley. It's a virtual conference with an amazing group of invited scientists, and a lot of the presentations are on YouTube. So I've been watching Joel Wallman from University of Waterloo talk about lessons learned from NISQ quantum computing, some really great presentations. So I recommend that we'll put it in the notes along with this podcast, but that everybody takes a look at these presentations, which are recorded. And there's a lot of really good information in them.
And it's a fascinating effort. I once had the privilege of teaching Jim Simmons, the founder of the Simmons Institute, the chicken dance at the wedding in California.
The chicken dance. Okay.
The chicken dance. We did the chicken dance. But Jim is the founder of Renaissance Technologies, the original quant hedge fund, where he was one of the first to argue that the more data we collect, that might be seemingly unrelated with Wall Street hedge fund investment returns, but trying to analyze and correlate it, the better we'll do a job. And he's considered pretty much the most successful investor in that respect. And out of SUNY Brook, one of the leading living mathematicians, but always with an eye on real world applications. And the Simmons Foundation is dedicated to that too. So to those who don't know about it, definitely check out the Simmons Foundation out of New York and Berkeley. It's a great.
And there's a newsletter that you can subscribe to get to get notice of all the events. So I'm now subscribed. André, what came up for you this week?
A very interesting survey by the QEDC that I'm frankly a little bit skeptical about, but I think most of us read it. They got 46 responses out of the entire quantum tech ecosystem, manufacturers, software developers, R&D, asking about the future due to this coronavirus pandemic. Roughly a third said that they will be facing drastic measures such as layoffs within 3 months. Half said they might face the same kind of struggles within 12 months. And the remaining 20% seemed fine. And that is obviously great data. Personally, I was a little surprised because it didn't really match my experience talking to people in the ecosystem that seem to be struggling a lot more. I have well over 300 quantum startups in my own database, and talking to them, I get the sense that way more than a third are really struggling in the very, very near term. But at least it's a much larger ecosystem than these 46 that we're looking at.
So wait a minute, André. Wait a minute. I started the IBMQ startup program in 2018, and there were 10 startups. And so you're telling me now you have 300 odd startups documented? That's amazing.
I have, well, that's my job. So when I don't enjoy Miami, I try to collect that data. If you can see my screen here, if you go into my members section, I collect a lot of different data. We'll actually check out some of these charts that I pulled up. This is less relevant, but quantum tech researchers, something that I do less good of a job at tracking. But just over the last 4 weeks, I got up to 223 researchers globally. Obviously, a lot of them in the US, probably a third of them in Europe, a good chunk in Japan. It's really difficult to get data out of China and Russia. But if we start to look more at the quantum venture kind of universe, we see that currently I have 312 companies in my list here that I'm actively tracking. And these are companies that I've been able to confirm. So spoken to or found public information to validate. And if you look at it, obviously a big chunk in hardware, 72 of them, a lot of them in software, 80, which is actually a little bit more. We have more and more consulting companies, media companies popping up. And then you have all the other QIS applications, such as QKD, quantum communications, and quantum sensing. Some of these companies that have been around for 20, 30 years, but started to get into quantum applications only recently, adding to the mix. Beyond that, I have government institutes and a whole list of research institutes that have a lot of spin-outs, commercial spin-outs that are more challenging to validate. And here you see we have regions such as Thailand. South Africa actually has a really big ecosystem, but Africa also. corners of Europe, India, Austria, Denmark, and so forth. So on the 312 that I'm able to confirm, there's probably another 100 to 150 that I have yet to truly validate.
So it's super interesting. If I can make a comment or maybe a question, it's very interesting to see how you still have today about the same number of hardware and software companies. It is a little less obvious than it actually sounds, because, for example, if you look at conventional or classical computing, is disproportionately different, the number of hardware companies and software companies. But in quantum computing, we're still at that phase, which is, again, not that different from the phase we were in classical computing a few decades ago, where hardware and software are still very much going in parallel in terms of numbers.
It is very interesting, yeah.
So,
and every week I come across a new company. Just this week, a full stack quantum computing hardware company, Alice and Bob, out of France, that has been around for 3 years. So it's always fun to see how they pop up.
Is there a geography that's particularly dominant?
It's you see a very equal distribution between the U.S. and the European Union. If you were to look at it as the European Union, the European Union actually is a little bit ahead in terms of volume, number of users, funding as well, except government funding. Europe is also a little ahead in terms of ecosystem. If you start to look at hardware components, suppliers, and some of the other QAS applications in QKD, sensing communications. If it's merely about quantum computing, hardware and software, the US is the definite absolute leader. But the big caveat is that Russia and China are big black holes that offer very little verifiable data, and it's difficult to check.
You know, and you haven't mentioned Canada, which surprises me because I think there's a lot going on in Canada.
My mistake. I mixed that into North America, and
Okay.
I shouldn't.
Okay.
Absolutely, Canada is a huge player in all of this. Us as Australia, obviously. And Japan has a great ecosystem with a government-funded program, a handful of very large universities, and a dozen companies and startups really pursuing this.
I also have a feeling you're forgetting Singapore.
So Singapore is on the list. Antropica Labs has been on the list for a while. So you see these little hotspots, as we also discussed last time, and you made that point, right? Switzerland, Austria, Singapore, and Denmark, other geographies, Spain, and all of that comes out of government concerted efforts around research universities. But there's a lot of people that I think we tend to forget in the ecosystem.
Mm-hmm. I think for being such a new and emerging technology, there's quite a healthy and large ecosystem, which is very amazing. And I think it speaks a lot on the promise of the technology that so many different people, scientists and business people are recognizing how impactful the technology can be.
Absolutely. I think one of the most fascinating things about quantum computing, or maybe I should say quantum information theory or quantum information science, is that, and again, this is a bit of a speculative statement and not everyone will necessarily agree with it, but especially in the last few decades, has been at the forefront of physics, and at a time when physics, it wasn't stagnant. I think that's absolutely too strong to say. But at a time where physics was getting a little bit, maybe, it was not able to replicate the great successes that we saw at the beginning of last century. Quantum information sciences became very much a new, interesting topic with a lot of great ideas, and I think that really contributed to attracting people who are intrinsically great. And the more we saw the overlap between physics and computer science, then you have people like Scott Aronson and that group coming into the picture as well really contributed to making a strong ecosystem. And I think now we are starting to, collect the fruits of that effort.
Absolutely, very collaborative, very active universe, and I think a lot of people are suffering tremendously in the current crisis, but also a lot of companies are doing really, really well and forging forward. And we will continue to explore that. We are 10 minutes over the time limit that we set ourselves. We could talk about this for a very, very long time. We will do so again next week. Denise, parting word is yours again.
Oh my gosh, the pressure. Everybody have a good week. Stay home and be safe. Thank you.
Thank you very much.
This was the weekly Quantum World Detangled, episode 2. You are now detangled.
Two.